with that said, let's take out your notebooks and we'll put this together. All right, so 3 different areas. Learning target number 1. Your mean equals your sum of data values divided by the number of data values. Okay. Best use of this, use it with symmetric data. i.e. there's no outliers. Okay? Relatively symmetric data is fine. But since there are no outliers to skew your mean's going to be the best average of what's going on. Okay? Your median is your middle point, or your middle value. Middle point of ordered data. And you're going to use this one skewed data. Because that way, remember, if I've got my list of numbers here, wow, that's going to be tiny for you. Maybe I should make that one bigger. We'll do it later. Or maybe now we'll do it later. Anyway, whoa, knocking over my setup. So what ends up happening is that if the number is here, and I move this point to this point, this number's still going to be there. So, okay. Learning target number 2, variability. Actually, let's call this one centers. So for variability, you've got a couple of different things. You've got range. And range is max minus min. Standard deviation. Square root of the sum of all your data minus your means squared. Then you divide that by n minus 1. Got to read my own handwriting here. Pause for a second. The way that you're going to write this out is this. The blank, and it depends upon what your context is. I'm going to say context there. So the number of colleges that the AP Stats class is applying to in groups of 4 typically varies by, and then you're going to put your standard deviation in. So like for us, 4 colleges from the mean of whatever your X bar is. X bar is your mean, by the way. You'll come to know and love that quite well. And then learning target number 3 is resistance. It's futile. Mean and standard deviation are greatly affected by outliers. Which means that they're non-resistant. Skewed data, so because of that, like we talked about before, if the data is skewed, use your median. if it is symmetric. Use your mean. Okay. So here's an example. Some students purchase pumpkins for the carving contest, blah, 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 blah. So they type it all in, histogram, actual data. You're going to calculate the mean weight of the pumpkins. So you're going to add all of this up and divide it through by what? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23. So X bar, and that's how I want you guys to write it down, because that means that you're talking about a mean. So 3.6 plus 4.0 plus dot, 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 plus 31 plus 33 divided by 23. It's going to equal 9.935 pounds. So what's the median weight? Look around, find the number in the middle. Now it's all ordered. Now it's not all ordered for you. Oh no, whatever are we going to do? So put weights in order. You're going to find the 12th one. Why the 12th one? Well, I've got 23 pieces of data here, right? And so it's kind of like, I would say you're going to kind of like block these off. And so if you had them all in order, you'd be like boom, 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 and you'd be left over. Think of it this way. If I've got 23 pieces of data, which I have, right? 23 pieces of data. If you average that, I'm going to get 11.5, which means that I have 11 pieces of data over here, and 11 pieces of data over here, and then I've got one in the middle. Instead of giving me one left over. So 22, 23. If you have, and again, just like before, if you end up having an even number of pieces of data, you're going to average those middle two. We'll talk more about that as we're going. Find the 12th numbered in the ordered list. So in that case, that's going to be 6.6 pounds. So would you use the mean or the median to summarize this? And why? Is it skewed or symmetric? It looks skewed to the right, Mr. Hayes. I've got an outlier over there. In fact, we might even have 2. Right. So you're going to say, I would use the median. Because the distribution of what? Pumpkin weights. Is skewed right. With 2 possible outliers. And then you're going to list out what those are, 31 and 33. Ta-da! I'm sorry, you can see that. There you go. Anyway, but that's how you go through and do that. So I'm going to have you guys do some practice problems on these. If you have any questions, shoot me an email. We'll see what we can come up with. Thanks.